Hello students, welcome to Infinity Academy class. In today's class, we'll discuss about expansion. In this chapter, we'll discuss expansion of some binomials like a plus b whole square, a plus b whole cube, and their minus also a minus b whole square and a minus b whole cube. And also, we'll discuss about the expansion of some trinomials, that is like a plus b plus c whole square and whole cube also, a plus b plus c whole cube, and there are some applications. So first of all, we all know about the expansion of a plus b whole square and a minus b whole square, that is a square plus 2ab plus b square, and a minus b whole square is equal to, you all know, a square minus 2ab plus b square. Now, what is the expansion of a plus b whole cube? This is a cube plus 3a square b plus 3ab square plus b cube. It can also read it as a cube plus b cube, that is taking these two terms together and taking 3ab common, this as 3ab into a plus b. So a plus b whole cube equal to, actually this is one formula. It has two forms, that is a cube plus 3a square b plus 3ab square plus b cube, and another form is a cube plus b cube plus 3ab into a plus b. We'll take these two forms in different cases, and later we'll discuss their examples and their applications also. And similarly, a minus b whole cube equals to a cube minus 3a square b plus 3ab square minus b cube. And similarly, it can be rewritten as a cube minus b cube minus 3ab into a minus b. So, from these two formula, this is number 1 and this is number 2, from these 1 and 2, we can get the formula for a cube plus b cube. Say, what is the formula of a cube plus b cube? Say, taking these two terms together, this term goes to this left hand side and it will become a plus b whole cube minus 3ab into a plus b. So what is the formula of a cube plus b cube? It is a plus b whole cube minus 3ab into a plus b. And similarly, what will be the formula for a cube minus b cube from number 2? It's simple. This is a minus b whole cube plus 3ab into a minus b. These two formulae basically are of same type. For that, if there is a plus sign, then take plus, minus, plus. If they are negative, then take negative, positive, and negative. And basically these two formula looks like a set. That is a cube plus b cube is a plus b whole cube minus 3ab into a plus b, and a cube minus b cube is equal to a minus b whole cube plus 3ab into a minus b. We'll take these two formula when the value of a plus b is given and also the value of ab is given, and you have to find a cube plus b cube or a cube minus b cube when a minus b and ab is given. Then we will follow these two formulae actually. So now let us discuss about some examples of this formulae, that is a plus b whole square and this a cube plus b cube or a plus b whole cube and a minus b. From this formulae for a plus b whole square, we can also make two formulae also, that is a square plus b square and a square minus b square, similarly as a cube plus b cube and a cube minus b cube. Follow these two formula from 3 and 4. What will be the formula for a square plus b square? It is nothing but a plus b whole square minus 2ab, and from 4 it will be a minus b whole square plus 2ab. Again we will follow these two formulae when a plus b or a minus b and the value of ab will be given, and you have to find the value for a square plus b square or a square minus b square. You also know about the formula for a square minus b square, another formula. Sorry. This will be again a square plus b square. Another formula for a square minus b square is also know a plus b into a minus b. This is actually a square plus b square. This is mistaken. So these are main formulae for this chapter. These are important formulae for this expansion chapter. We'll use this formulae for some applications, for some problems we'll discuss in next time. Okay. So let us note this formulae for your use in expansion chapter, that is a cube plus b cube and a cube minus b cube and a square plus b square in two forms. One form is for a plus b and another is for a minus b, and another formula is for a square minus b square. Now let us take some examples or some application on this expansion. Let us take an example. This is if x squared plus 1 by x squared equals to 7, then find x minus 1 by x. It is very simple. Using the formula for a square plus b square, that is x squared plus 1 by x squared equals to 7, it is given. So simply say that it is nothing but x whole square and it is 1 by x whole square, right? It is x squared plus 1 by x whole square. So it looks like a square plus b square, where a is x its whole square and b is 1 by x its whole square. So it is nothing but it will follow the formula for a square plus b square, right? And which formula you have to take? Which form you have to take? You have to take a square plus b square equal to a minus b whole square plus 2ab. Why? Here you have to find x minus 1 by x, right? Here you have to find x minus 1 by x. That is, you have to find a, that is x, and minus b, that is 1 by x. So you have to follow this formula in this case. If you have to find x plus 1 by x, then you have to take the formula for a square plus b square, which is a plus b whole square minus 2ab, right? So when you have to find x minus 1 by x from the square sum, then you have to follow this negative formula. And when you have to find the sum of x and 1 by x from the square sum, then you have to follow this sum formula, that is a plus b whole square minus 2ab. So here we will use this formula, right? So here we can write x minus 1 by x whole square plus 2 into a means x, into b means 1 by x, right? That is equal to 7, correct? So it is x minus 1 by x whole square, it is nothing but 2, that is equal to 7 minus 2, right? Then it will x minus x whole square, it is 5. So you have to find x minus 1 by x, right? So you have to take the square root for, in both sides, right? That is, it is nothing but root 5, correct? That is, if x square plus 1 by x square equals to 7, then the value of x minus 1 by x is square root of 5, correct? Let us take another example. Another example or another application of this expansion of squares, right? Second example is a square. If a square minus 4a minus 1 equals to 0, then find the value of a square plus 1 square. It is different type of problem, but we can use the same form of the expansion. just see that the form, that is a square minus 4a minus 1 equals to 0. See, if we divide, these terms or this equation by a, that is if we divide by a on both sides, then it will a minus 4 minus 1 by a equals to 0. Correct? Then from this we can write a minus 1 by a equals to 4. Then it is simple. That is, you have the value of a minus 1 by a. Then you have to find a square plus 1 by a square. You all know what will be the answer, right? Just comment upon it. It is a minus 1 by whole square plus 2 into a into 1 by a. That is, here we use the form of a square plus b square as a minus b whole square plus 2ab. Correct? Then you can put the value of a minus 1 by a here. That is 4 square plus 2. Correct? That is 16 plus 2 equals to 18. That is the answer for a square plus 1 by a square. That is, if a square minus 4a minus 1 equals to 0, then you can find the value of a square plus 1 by a square. Right? Now let us take another example, another kind of problem. These problems are different kinds, so we'll discuss every type of problems on this chapter, and we'll do some exercise of all kind of problems. Next example, example 3. If x plus 1 by 5x equals to 3, then find the value of 25x squared plus 1 by x squared. If x plus 1 by 5x equals to 3, then you have to find the value of 25x squared plus 1 by x squared. See, if you take this as a and this as b, that is a plus b equals to 3, then you can find a square plus b square, right? That is x square plus 1 by 25x square. But here you have to find 25x square plus 1 by x square. That is, coefficients are interchanged, right? If the coefficients are interchanged from this required term, in this required term, then you have to change the coefficient in the given term, right? See, this is given x plus 1 by 5x equals to 3. Then you have to change the coefficient of this term to this term, and you have to change this coefficient to this term. That is, you have to make the coefficient of x as 5, and you have to make the coefficient of 1 by x as 1. Now multiply on both sides by 5. Then it will 5x, and it will 5 by 5x, and it will 15, right? Then what happened? Then the coefficient of x becomes 5, and coefficient of 1 by x changes to 1, right? Then it becomes 5x plus 1 by x equals to 15. Then you can take this as a and this as b to find this 25x square plus 1 by x square, right? You can take this as a and this as b. That is, a plus b is equal to 15. You have to find a square plus b square, right? Do this. Now we can find 25x square plus 1 by x square as a square plus b square, where a is 5x, that is it is 5x whole square and it is nothing but 1 by x whole square, correct? So this will be 5x plus 1 by x whole square minus twice into 5x 1 by x, right? Then this value is already known, that is 5x plus 1 by x equals to 15, that is 15 square minus 10 twice into 5, 2 into 5, correct? And this will be 2 to 5 minus 10 and it is 215. This is very simple. So if x plus 1 by 5x equals to 3, then this equals to 215. What is the funda of this kind of problem? You have to change the coefficient of these two terms. You have to interchange. Basically, you have to interchange the coefficient of these two terms. Basically, you have to see if there are any interchange in between the squared coefficient, then you have to interchange this coefficient. Simply multiply the coefficient, simply multiply both sides by the coefficient that you have to interchange, right? Here we have to interchange the coefficient, that is 5. We have to take 5 there and 1 there, so you have to multiply 5 on both sides for this problem. So for this kind of problem, you have to basically interchange the coefficient. This is the funda of this kind of problem. Another kind of problem you have to face in this chapter, that is expansion, value of some squares of some big integer like 102 square. If you have to find 102 square using expansion, not in normal method, you have to use expansion. What you have to do? That is, you have to do 100 plus 2 whole square. That is, you have to break this number in between two numbers whose square you can find easily. That is, you have to express this as a plus b or a minus b form, right? Then it will of the form a square plus 2ab plus b square, right? Then you can easily find this. That is 100 square means 10,000 plus 400 plus 4, correct? That is 10,404. And in similar manner, you can also find 98 square. How can I write this? This is 100 minus 2 whole square, right? So it is nothing but a minus b whole square. So it will be 100 square minus 2 into a into b plus b square, correct? Easily you can find this, right? Comment your answer in this comment box, okay? Now take another type of problem. This is type of proof. What kind of proof? That is, if 2a minus b plus c equals to 0, then prove that 4a square minus b square plus c square plus 4ac equals to 0. That is, 2a minus b plus c equals to 0 is given. From this relation, we have to prove this relation between a, b, c. It is very simple. That is, 2a minus b plus c equals to 0 is given means 2a plus c equals to b, correct? You have to move this b or a right hand side, correct? Then you can take square on both sides. That is, I take square on both sides. That is 2a plus c whole square equals to b square. Then expand this. That is 2a whole square. That is a plus b whole square formula. 2 into 2a into c plus c square equal to b square. So it is 4a square plus 4ac plus c square equals to b square. So again, I can move this b square to this left hand side. It is 4a square minus b square plus c square plus 4ac equals to 0. That is proved. Correct? So these are various kind of problems involved in this chapter expansion. So you can do these problems, do this kind of problems from exercise, and if you face any problem uh, to solve this, you can directly WhatsApp to our WhatsApp official number, that is 8420702948. Okay. Uh, this is about expansion of binomials. In part 2, we'll discuss about expansion on trinomials. Okay, right.